Today we're going to look at linear inequalities, systems of them, and we're going to start the linear programming part of our chapter. So review, sketch the following inequalities. So if you remember, when x is greater than 3, this will be a vertical line because all along a vertical line x is equal to 3, at 3. And since there's not an equal sign, it will be dashed. So at x equals 3, I will draw a dashed line to represent the answer can't be on the line. And we're going to shade where everything is greater than that, so to the right. The next one, we want to know where y is less than or equal to negative 4. So we'll find where x is negative 4. It will be a solid line because of the equal sign, and y is less than negative 4 below the line. If you remember, we graphed something like this last unit. We got y by itself first. So let's do that. Let's add 2x to each side. We get 3y is greater than or equal to 12 plus 2x, and we divide it by 3. So that we could get y by itself. So we have y is greater than or equal to 4 plus 2/3 x. And then we were able to graph it with the slope and the y-intercept. So the y-intercept here, oops, I was going to erase that. The y-intercept is 4. 1, 2, 3, 4. Our slope is 2/3. It means you're going to go up 2 over 3. I'll do it a few times, up 2 over 3. You can go backwards, but go down and to the left. And it's a solid line because of our equal sign. That's not great. Let's do it again. And then we are going to pick a point, test, and shade. Let's choose 0, 0. We can plug it into the equation. Is 0 greater than or equal to 4? And remember, this turns into a 0. And is that true or false? So this is actually false. 0 is not greater than 4. So we're going to shade the other side of the line where that point 0, 0 is not, because 0, 0 is false. Okay, before we get to this, let's go here. I forgot to erase. Okay, so one thing we didn't talk about last chapter is that when you divide by a negative, multiply or divide by a negative in an inequality, when you're trying to get y by itself, you have to switch the sign. And so I'll do an example and I'll explain why. So let's say we have 4x minus 2y is greater than 10. And we're trying to get y by itself. So first step, we will subtract 4x from each side. And when we do that, we will get negative 2y is greater than 10 minus 4x. We will divide by negative 2. And when we do that, we will get y. But now we switch the sign because we divided by a negative. So now y is less than, I'll change colors here, negative 5 plus 2x. So here's the new inequality. All right, so again, we switch the sign because we divided by a negative. Here's why. So let's imagine we start with negative 4, which is less than 7, and that is true. Negative 4 is less than 7. Let's say we multiply each of those sides by negative 1. We will get 4 is greater than negative 7. So notice we switch the sign when we multiplied by a negative. All right, let's do the same with division. We know that 5 is less than 9. Divide each number by negative 1. We'll get a negative 5 and a negative 9. But now we know negative 5 is greater than negative 9. So again, if we're solving for y and we have to divide by a negative, we switch the direction of the sign. Okay, let's go back to this problem. There's another way to graph this called the cover-up method. And so the cover-up method, again, to draw a line, we need 2 points to graph. So let's say we want to find one of the points by making x, let's make this into a 0. So let's say x is 0. What I'm going to do is kind of cover that up, and I'll imagine that 3y equals 12. And if we do that, we're going to get y equals 4. So when x is 0, y is 4. So that's called the cover-up method. You cover one up and you solve. And so 0, 4 I'm going to graph right here. All right, now let's cover up the other thing. So let's imagine that y is 0. So if y is 0, we would cover this up. And we would have negative 2x, and let's say that's equal to 12. And we could solve. And we have x equals negative 6. So when y is 0, x is negative 6. And so we can cover one up to solve, cover the other up to solve, and we will get negative 6, 0. And then again, if we take a look at the inequality, it's a solid line because of the equal sign. We'll pick a point, test, and shade. And so again, 0, 0 is pretty easy to pick, and it's even easier to plug in 0, 0 in this kind of equation because we get this whole thing as 0. Is 0 greater than or equal to 12? And 0 is not greater than or equal to 12, so again, that's false. We're going to shade above the line. And notice that matches this graph up here. So we'll practice that cover-up method throughout the unit, where we cover one up, solve, cover the other up, and solve to get 2 points to graph. Okay, so we'll set that aside for a second, come back to it. We are starting this part of the unit called linear programming. The practice of graphing linear inequalities to find a region where all of the inequalities is true is called linear programming. And this has a lot of real-world applications. So linear programming you can use to find maximum values, minimum values. So here are just some examples. If you're in food and agriculture, you can determine what crops should grow, the quantity of it, and how to use it efficiently. And by doing so, you're going to increase your revenue. Transportation, you can look at optimizing profits, looking at scheduling, and so on. Manufacturing, again, maximizing profits, you can minimize time needed, and so on. So linear programming is actually used a lot to figure out how to save money or make money. So let's do the first example. We're going to sketch a feasible region, and a feasible region is where it's shaded for all regions. Feasible means it's possible. So we're looking for where all the possible answers for all of these regions. So the first one, we're going to graph x is greater than 3. All right, so it's a solid line where x is 3. So I'll do this one in purple. And we want to know where x is greater than or equal to 3, so here it is. All right, the second one I'll do in red, where x is less than or equal to 7. So 3, 4, 5, 6, 7. Solid line at 7. And we want to know where x is less than or equal. It's everything to the left, but since I'm only looking for the feasible region, where it's true for all, we're going to do this part right here. Okay, next, let's graph where y is less than or equal to 10. So I'm going to find 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 is up here somewhere. So we want to know where y is less than or equal to 10. Again, it's everywhere, but we're only going to shade in the region that's already shaded. So we're going to triple shade this region. And the last one, we're going to graph where y is greater than or equal to negative x plus 8. So this starts at 8. And it has a slope of negative 1. And it's a solid line. And let's pick the point 0, 0 to plug in. Is 0 greater than or equal to negative 0, which is 0, plus 8? Is 0 bigger than 8? That's false. So here's 0, 0. We're going to shade on the other side of the line, so everywhere up here. But again, we're only going to shade where it's already triple shaded, and we're going to quadruple shade. So this is the feasible region. I'll use like pink. I'll make it a little bit thicker. All right, so right here is this feasible region where it's true for all of these inequalities. Okay, so that is graphing inequalities to find a feasible region. Where is it true for all of the inequalities? And it's in that quadrilateral. All right, so our goal here is we're going to practice writing constraints, and we're going to practice graphing a system of linear inequalities. So here's the investigation. Ezra has $100 saved up from previous tie-dye sales. From his short stint working at Rainbow, he is going to make his next batch of merchandise to sell. He would like to purchase some more sweatshirts and t-shirts to tie-dye. He found a store that gives him a pretty good price on these items if he spends a minimum of $50. The store sells t-shirts for $5 and sweatshirts for $10. He wants to buy at least twice as many sweatshirts as he does t-shirts. All right, so first step, define the variable. So I'm just going to call x the number of sweatshirts. And I'll call y the number of t-shirts. All right, I'll write the constraints for the problem. So one of the constraints is that the store sells t-shirts for $5 and sweatshirts for $10, and he only has $100 saved up. Okay, so let's write that one first. Okay, so we could say $10 for every sweatshirt, $5 for every t-shirt, and we can spend less than or equal to $100. So there's the first one. The next equation is he has to spend a minimum of $50. So again, it's $10 per sweatshirt, $5 per t-shirt, and he has to spend a minimum of $50, so greater than or equal to $50. Okay. And then the next constraint is that he wants to buy at least twice the amount of sweatshirts as he does t-shirts. right, so when we write that down, so for the sweatshirts, he wants to buy at least twice the amount of sweatshirts as he does t-shirts. So here's twice the number of t-shirts to y. Okay, so now we're going to graph these using the cover-up method or by solving for y. So we could solve each of these for y. Since we haven't practiced using the cover-up method, I'm going to do that right here. Okay, so the cover-up method, let's do it in green. Let's do this one first. So let's say we cover up x. We would get 5y equals 100. So y would be 20. Okay, let's cover up the y. Okay, so imagine that's 0. So if that's 0, we would say, all right, 10x equals 100. So divide by 10, x would be 10. Okay, so we have 2 points here in green. Let me erase this again. Okay, so the 2 points in green are 0, 20, and 10, 0. So again, we covered one up, assuming it was 0, and we solved. So there's the first graph. So I'm going to go to this page, and we're going to graph. Actually, let's solve for everything first and then graph. Okay, so here's the first one. Let's do the second one. Again, I'm going to erase some of this so I can show my work. All right, so the second one in purple. Let's cover one up. So let's cover up the x. So if x is 0, we have 5y equals 50. We'll divide by 5. So y equals 10. Okay, so there's the first part. Here's the second part. Let's cover up the y's. All right, so if we have 10x equals 50, so if y is 0, we solve, we'll divide by 10. And so if we do that, we get x equals 5. Okay, so we have 2 points here. The first one was 0, 10, and the second one is 5, 0. Okay, and then the last one, if we are to graph it, I'm just going to get y by itself here. So to get y by itself, I'm just going to divide by 2. And so we have x over 2 is greater than or equal to y. All right, so these are the 3 things that I will graph. So I'll do the green one first. So I know my graph has to go at least up to 20. So I think I can just scale by ones. Yeah, that works. So I will scale. Let's look at how we label these. So x is the number of sweatshirts. So I'll write that number of sweatshirts. And then y will be the number of t-shirts. So let's do y, number of t-shirts. Okay. So number of sweatshirts, again, I'm just going by one. So let me scale this. 1, 2, 3, 4. Here's 5. Here's 10. Here's 15. Here's 20. Here's 25. And then let's do that over here. 1, 2, 3, 4. Here's 5. Here's 10. 15, 20. Okay, so now let's graph. I'll do the green line first. Okay, so 0, 20 I'm going to graph. So 0, 20 is right here. And 10, 0. So 10, 0 is right here. And that's going to be a solid line. Okay, so there's the first one. We pick a point, test, and shade. So if I plug in, is 0 less than or equal to 100, and it is. So here's the point 0, 0. We're going to shade below the line. Okay, let's do the next line. The next line, we have points at 0, 10 and 5, 0. So 0, 10 is right here. 5, 0 is right here. Again, a solid line because of the equal sign. Pick a point, test, and shade. Is 0 greater than or equal to 50. So here's 0, 0. And 0 is not bigger than 50, so I'm not going to shade this side of the line. I'm going to shade above the line. So our double shaded region is between the lines. In our last one to graph, we're graphing the line x over 2, which is 1/2, which means the y-intercept is 0, and the slope is 1/2. So we start at 0. We're going to go up 1 over 2, up 1 over 2 in each direction. And it's a solid line. I didn't do that very well. All right. And again, pick a point, test, and shade. Here's one where you can't plug in 0, 0 because that's on the line. So I'll just pick a point. I'll pick this point right here, which is 3, 0. And let's plug in and see if that's true. So again, I'm plugging in 3, 0 right here. All right, so 3 over 2. Is that greater than or equal to 0? And that's true. So we're going to shade the side of the line that 0, 0 is on. So that's, or that 3, 0 is on, that's below the line. So we're going to shade below the line. Okay, so here's the feasible region. I'll do it in red. Okay, so this area is where it's triple shaded. Anything on the line or inside the line here would work for Ezra to pick that many number of t-shirts and sweatshirts. All right, so then it says, can you give 3 combinations of t-shirts and sweatshirts that he could make? Oh, first, what are the vertices? So the vertices are the corners. Okay, so the vertices are the corners. So the vertices would be 5, 0, 4, 2, 10, 0, and 9, 1, 2, 3, 4, 9, 4. So these are the vertices, and anything on these points would work. We could buy 5 sweatshirts, 0 t-shirts, 4 sweatshirts, 2 t-shirts, and so on. So any 3 of those would work. You can also pick anything inside. So another combination that would work would be like 5, 1 or 5, 2. Oops. We could say 6, 1 would work. So any of these combinations of t-shirts and sweatshirts would work. Something that would not work, you could not do like 15, 0. You could not do like 0, 10. Anything outside. All right, so for your assignment, you will be graphing the inequalities and shading and then trying one word problem. And then some review.